Hi, hello students, teachers, parents and all stakeholders. Welcome to class 8 mathematics. This is yours Kona Reddy. So in the series of videos we are doing Ncert exemplar problems, that is of class 8. In my previous video I did problems 1 to 25 of rational numbers. Now here in this video let us start from 26th problem. Before going to start the lesson, if you like my explanations, please like, share and comment, and before that please don't forget to subscribe my channel. And if you want to see my previous video, I am giving the link in the description. You can watch the video by using that link. Yeah, let us quickly go through the problems. Okay, 26th problem. You see the equivalent of 5 by 7 whose numerator is 45. So here you observe here 5 by 7 we have. Numerator is equal to how much? 45. So you observe here 5 is in the numerator here in this case. To get 45 you need to multiply with 9. So multiply both numerator and denominator by 9. So this will be equal to 5 times 9 is 45, then divided by 7 times 9 is 63. So the answer for this one is 45 by 63. Next let us go to 27th problem. The equivalent rational number of 7 by 9 whose denominator is 45 in this case. The denominator is 45. So here the given number is 7 by 9. We need to get the denominator equal to how much? 45. Here in the given number the denominator is how much? 9. To get 45, what shall we do? Just multiply both numerator and denominator by 5. So 5 by 5. So that this becomes 7 times 5 is 35, then divided by 9 times 5 is how much? 45. So the denominator becomes 45. So the equivalent number for 7 by 9 is 35 by 45. That is here in this case. Now 28. Between the numbers 15 by 20 and 35 by 40, the greater number is. That means we have here 15 by 20 and 35 by 40. Here we have two numbers. Out of these two, which one is the greater number? That is what we need to find out. How to compare two rational numbers? By equalizing the denominators. That means we need to change the fractions or the rational numbers into like fractions. Like fractions, what are like fractions? The fractions which have same denominators. Those are said to be like fractions. So we need to convert these two into like fractions. For that we need to observe the denominators. What are the denominators? You observe 20 and 40. These are the denominators. We need to equalize these denominators. Simply just multiply 20 with 2 so that you will get that is the denominator equal to 40, and so that the denominators will be equal. So what we do here is take 15 by 20, multiply numerator and denominator by 2. So 2 by 2, which is equal to 15 into 2 is 30 divided by 40. 20 into 2 means 40. The other number is what is that? 35 by 40. Now the denominators are equal. So just compare the numerators. 30 and 35. Between 30 and 35, which is the greatest one? 35 is the greatest one. So among the given two numbers, 15 by 20 and 35 by 40, which is the greatest one? That is 35 by 40 is the greater one. So this is the answer. Okay, right. Next, 29th one. The reciprocal of a positive rational number is reciprocal. Means suppose P by Q is a rational number. What is the reciprocal of this one? Simply switch or swap the numerator and denominator. So it will be Q by P. So here we are not changing the sign. So if you take a positive rational number, then the reciprocal will also be positive. Similarly, if you take a negative rational number, then the reciprocal is also a negative rational number. You take one example for this one. Suppose if I take 3 by 4, then the reciprocal of this one is 4 by 3. So both are positive in this case, right? So reciprocal of a positive rational number is, what is that? Positive. So positive rational number. Positive rational number. So that is for 29th one. Now let us see 30. The reciprocal of a negative rational number, as we have discussed in problem number 29, the reciprocal of a negative rational number is also a negative rational number. So negative rational number. So if you want to take one example, we can take, suppose if we take negative 3 by 4, the reciprocal of this one is a negative 4 by 3. So both are negative. Right, okay. Next, let us go to 31. 0 has dash reciprocal. First of all, does 0 has any reciprocal? There is no reciprocal. Why? Because if you take 0, we can write 0 as 0 by 1, 0 by 2, or 0 by 3 like that. Let me take 0 by 3. So the reciprocal of this one is how much? 3 by 0. Division by 0 is not possible. So 0 has no reciprocal. 0 has no reciprocal. Right. Next, 32nd one. The numbers dash and dash are their own reciprocal. That means we have two numbers for which the reciprocal is the number itself again. We have two such type of numbers. One is 1 and other one is negative 1. Okay. If you take 1, the reciprocal of 1 is 1 by 1. So 1 by 1 means 1 again. So again we will get the same number. Similarly, if you take negative 1, reciprocal of negative 1 is negative 1 by 1, which is negative 1 again. So we will get same number again. So 1 and negative 1 are said to be own reciprocals. Right. So let's go to the next one. 33rd one. If y be reciprocal of x, then the reciprocal of y square in the terms of x will be. Here, observe the question carefully. Y be the reciprocal of x, that is given. So we can write reciprocal of x, that is 1 by x, equal to y. So y equal to 1 by x. Now, then reciprocal of y square. So reciprocal of y square we need to find out. Reciprocal of y square. Reciprocal of y square is nothing but 1 by y square. So that is equal to 1 by, in the denominator y square we have, but we know the value of y, that is 1 by x. So write 1 by x whole square. That means what we are doing here, instead of y we are substituting, that is 1 by x in the place of y. In the place of y we are writing 1 by x. So this is equal to 1 by x whole square is equal to 1 square, means 1 divided by x square. So that is equal to 1 times 1 by x square is in the denominator. If you bring that one to numerator, we need to take the reciprocal. So it will become x square by 1. So that is equal to 1 times x square by 1 means x square. So the answer for 33rd problem is x square. Okay, let's go to 34th problem. The reciprocal of a number is given here. First, let us simplify this number. So 2 by 5 times negative 4 by 9. This is what we have. This is equal to minus 2 times 4. Multiply the numerators. That will be 8 divided by 5 times 9. Multiply the denominators. 5 times 9 is 45. Now the reciprocal of negative 8 by 45 is negative 45 by 8. So this is the answer. Now let's move on to 35th problem. 213 times 657 whole to the power of negative 1 equal to, so we are given here 213 to the power of negative 1 times. So we know that a times b whole to the power of m equal to a to the power of m times b to the power of m. This is the identity you need to remember in this case and you need to use in this case. Now in the place of a, let us take 213, then times b. In the place of b, let us take 657. And in the place of m, let us take negative 1. So this will be equal to a to the power of m. That means 213 to the power of negative 1 times b to the power of m, that means 657 whole to the power of negative 1. From this you can say that in the blank it should be 657 whole to the power of -1. That is the answer. Or you can still simplify this one. You can write this one as 1 by 657 also. You can write this one as the answer or this one as the answer. Both are correct. Then 36th problem. The negative of 1 is -1. That's it. Right. Okay. Now let's go to the next problem. 37th problem. For rational numbers a by b, c by d and e by f, we have a by b times c by d plus e by f equal to. This is nothing but distributive property, right? Suppose you have a times b plus c, then this can be written as a times b plus a times c. That is what distributive property. We can use same property here. A by b times, we have something within the brackets, multiply like this, a by b times c by d. So here a by b times c by d plus, then we have a by b times e by f. So a by b times e by f. That's it. That is the answer. Or you can write a by b times c by d as ac by bd. Here also this can be written as this is equal to AE by BF. So in the first blank you can write AC by BD. In the second blank you can write AE by BF. That's it. This is simply distributive property. Now let's go to the next 38th problem. -5 by 7 is dash than -3. That means we need to check -5 by 7 is whether it is greater than -3 or less than -3. That is what we need to check. So that means we need to compare -5 by 7 and -3. Now how to compare rational numbers? By changing them into like fractions. So here -5 by 7 is one number. Then we have -3. Now we need to change these two into like fractions. In the first fraction we have 7 as the denominator. In the second fraction we don't have anything in the denominator. Of course you can write 1 as the denominator. We need to make the denominator as 7. For that what we do? Just simply multiply this number by 7 and divide by 7. So this will be equal to -3 times 7 is -21 divided by 7. Now we need to compare this -5 by 7 and -21 by 7. Which one is greater among these two? -5 by 7 or -21 by 7? If we ignore these negative symbols, then we have 5 by 7 and 21 by 7. So clearly 21 is the greatest one if we ignore the negative symbols. But if we take negative symbols also into consideration, -5 will be greater than -21. So -5 by 7 will be greater than -21 by 7. So here -5 by 7 is greater, or we can say more than or greater than -3. Okay, right. Let's go to 39th problem. There are dash rational numbers between any two rational numbers. There are infinitely many rational numbers between any two rational numbers. So we can write infinitely many. Okay, so there are infinitely many rational numbers between any two rational numbers. Okay, right. So let us go to 40th problem. The rational numbers 1 by 3 and -1 by 3 are on the dash sides of 0 on the number line. So on the number line, if you take this as the number line, suppose this is 0, then where will be this 1 by 3 and -1 by 3? Suppose here is -1 by 3. On the right side also at the same distance from 0, that will be +1 by 3. So on the number line, this -1 by 3 and +1 by 3 are on opposite sides. So 1 by 3 is at right side and -1 by 3 is at left side. So we can say these two, -1 by 3 and +1 by 3, these two are on opposite sides of 0 on the number line. So we write here opposite. Right. Okay, next let's go to 41st problem. The negative of a negative rational number is always a dash rational number. Negative of negative becomes positive. Suppose if you take negative of negative, so minus of -4 if you take, that will be minus into minus is plus. So +4 you will get. So the negative of a negative rational number is always a positive rational number. Positive rational number. Now let us go to 42nd problem. Rational numbers can be added or multiplied in any dash. Rational numbers can be added or multiplied. That means, suppose if you take A and B, two rational numbers, A plus B or A times B, we can add or we can multiply in any dash, means in any order. That means you can add A plus B or you can add B plus A also. Similarly, you can multiply A times B or B times A also. So in any order, we can add or we can multiply two rational numbers. Now next 43rd one. The reciprocal of negative 5 by 7 is, reciprocal is simply switch the numerator to denominator and denominator to numerator. So we will get 7 by 5. Now this minus symbol, for which one we need to put minus symbol? You can put this minus symbol for 5 or for 7 or for entirely the fraction. So you can write like this also. So negative 7 by 5. Let's go to the next problem. 44th one. The multiplicative inverse of 4 by 3. Multiplicative inverse and reciprocal both are same. So for 4 by 3, the multiplicative inverse is 3 by 4. Simply switch numerator and denominator. That's it. Next one, 45th one. The rational number 10.11 in the form P by Q is. Now how to convert decimals into fractions? Here we have 10.11. See how I am converting this. First, simply ignore this point, then write the entire number. That means 1011. So ignore the decimal point and write the entire number. Then divided by, after the decimal point, you count how many digits are there. After the decimal point, 1, 1. That means 2 digits are there. So put 100. Right. So the answer for this one is 1011 by 100. Let me take one more example for this one. Suppose we have 7.8. How to convert this into fractions? First ignore the decimal point and write the number. So 78 divided by, after the decimal point we have just one digit. So write just 10. That means put 1, then beside that put 10, because after the decimal point we have one digit. Suppose we have 8.697 like this. How to write this one? Ignore the decimal point. 8697 divided by, put 1 here. After the decimal point, how many digits we have? Count them, 1, 2, 3 digits. So put 3 zeros here. That's it. Now let us move on to the next problem. 1 by 5 times 2 by 7 plus 3 by 8. So this looks like this is A times B plus C. So this is clearly distributive property. We can write this one as A times B plus A times C. So 1 by 5 times 2 by 7. Then A times C means A is 1 by 5 times C is how much? 3 by 8. So 3 by 8. So this is the answer. Now 47th problem. The two rational numbers lying between negative 2 and negative 5 with the denominator as 1 or dash and dash. Denominator is 1. What does it mean? For any integer, the denominator is 1. So, in other words, we need to find out the integers between negative 2 and negative 5. What are the integers we have in between negative 2 and negative 5? Negative 3 and negative 4. Now, you can write negative 3 as negative 3 divided by 1 and negative 4 as negative 4 divided by 1. That's it. So, the answer for this one is negative 3 in the first blank and negative 4 in the second blank. With this, fill in the blanks. Problems are over. Right. Let us do the next problems in my next video. Hope you like my explanation. If you like my explanation, please like, comment, share, and before that, please don't forget to subscribe my channel. Yours, Kona Reddy. Thank you. Thanks for watching.